and it is LeetCode number 50. Okay, the question states that implement power of x power n, which calculates the x raised to the power n. Okay, this is a simple thing that you can understand. If suppose that, let's say they are asking 2 power 10, 2 power 10. Okay, in general, how you can calculate 2 into 2 into up to so on 10 times, 10 times. So this is a simple thing. So you can generally think of like a while loop, which is calculating or multiplying 10 times. So this is this is known as brute force approach. You can apply the brute force approach, that's not an issue. But there is an issue, because so here you can see the code for the brute force approach. This is known as iterative approach. Okay, and 2 power 10 is 1024, and here they're asking 2 cube, which is 8, but they're asking in decimal, so given in points, so we need to calculate exactly 9.26100 is our answer. Okay, here you can also see they're giving in negatives means what, 2.000 power minus 2, which is 1 divided by 2 square, means approximately I am doing that. So this gives rise to 1 by 4. So what you understood? What you understood is, generally if they are asking 2 power minus 2, first we need to calculate 2 power 2, and we need to take 1 by that. Okay, so if you do that, you will get negative exponentials. So that's not a difficult issue. So first of all, the first approach that is the iterative. So while loop. So inside this while loop, what we are going to do is we are going to have the answer is equals to answer times the x, which if you want the x power n, we are going to go to 1 to n, and we are going to calculate x means the x power n in this fashion. So this is the iterative approach. So suppose let's say they are asking x power minus n. So in the same way, first you calculate x power n. Okay, in the same way you calculate x power n, and finally after this you can do x is equals to 1 by x power n. So same thing. So this is your answer. How? Because so if you want minus x power minus n, you simply do 1 by x power plus n. That's it. So we have understood with the help of simple iterative approach as well. So if you want to see the code, so this is the code. So they're asking power, so x, and they're giving n. So for answer I am taking long capital N, and this is the simple check. If they are giving the negative integer, we are going to first invert that number, and we are going to convert n is equals to minus n. Okay, and we are taking the double as answer, because you can see answer is possible in double. Answer can also be possible in double. So take double as answer, and do a for loop, do a or while loop, that is your wish. Okay, so from 0 to n, 0 to capital N, and increment all the values with the n, and finally return that value. This is as simple as that. That's why I'm not going to in depth explain this topic, but the next topic, the approach 2, is very important. So before that, we are going to understand the time complexity, which is order of n, and the space complexity is order of 1. Why space complexity? You can see here we are running one loop. As we are running one loop, with the help of this one loop, we are getting the time complexity order of n, and we are not consuming any extra space. So that's why the space complexity is order of 1. So the next approach, the approach 2, which is very important, the approach 2. So in this, what we will do is, let's say we want x power n. If n is even or n is odd, based on that we are going to do something. So we can say this topic is on the binomial expansions. So if this n is even, so then what we are going to do is x power n, how we can write that as x power n by 2 and whole by 2. Is this making some sense? Because these two will be cut down, and we are going to left out this x power n as this. So you might be getting it out why we are representing this x power n as in this fashion. So I will explain so that you can understand very clearly. So if you take an example so that you can understand very clearly. So let me take an example as 2 power 10. If you suppose if I want to calculate 2 power 10, so how can I represent this? 2 power 5 whole square. So instead of calculating 2 into 2 into 2 into up to 10 times, this huge button, this is brute force. So instead of what I am doing is, just I will calculate the multiplication of 5 times only, and I will just square it. So this reduces half of the work. So with the help of recursion we can do that. Okay, so if that is only n is even, that is possible. Okay, this is n is even. Let's say n is odd. let's say n is odd. So then how we can represent this x power n as? So we can represent x power n as x into x power n minus 1. Can you see? So if you multiply these two, so we can say x power 1 plus n minus 1. I'm just not doing nothing. One this plus this plus this. So this cancel, and ultimately you are going to get this only, this. So x power n you are getting. So what is the use that representing this as this format? So yeah, for that also I will going to show you an example. Let's say you have 2 power 5. You need to calculate this exponential. So you can express this as 2 into 2 power 4, right? In this fashion. So yeah, you can think, instead of calculating 2 into 2 into 2 into like that 5 times, so simply you can do 2 and multiply it by 2 power 4, and this we can get with the help of recursion. So this is the, if n is odd, this is n is odd, and this concept is n is even, and this whole concept is approach 2, as you can see, or we can simply call it as binomial expansion. Okay, so first of all I will explain the code. I will try to explain the code. So after that I will going to explain the recursion tree so that you can understand very well clearly. Okay, so first of all you can see clearly over here I am just doing nothing. So I am taking capital N as n, the given n means the exponential power. So I am checking that if that exponential power is the negative value or not. If that's negative value, I'm going to do something. Okay, I'm just inverting that. So if that's not, I'm just calling the function called solve, and I'm passing. So after that, the whole masala is going on here. So what's going on here? Let's clearly observe over here. Okay, in the solve function, we are having a double, means the x and to the power n that we need to calculate. So first of all, we know the steps. What are the steps we know? First, we need to calculate the base condition. Okay, always remember that first we need to see the base condition. After that we need to calculate the required condition. After we need to calculate the required condition, and finally we are going to call the recursive functions recursively. Okay, so if you see, if n is 0, we are going to return 1 directly. If that is not the case, we are going to do half of that. If n is even, we are going to calculate the half into half. If n is odd, and we are going to calculate this x into half square. So I hope you don't generally first time hearing means you will not understand these two steps. So let me dry run these 2 steps and show clearly in the in the tree format so that you can understand clearly. So before going to explain, so let me write something that each function call, okay, each function call in the recursion stores something. So if you understand this, you can understand each and every recursion topic. Okay, so what each function call will store? So each function call will store parameters. This is very important. Parameters and local variables. Each function call, remember, each function call stores all these, and the return values. So return address it will store, and execution position. So all the four will be having for each and every function call that we are calling. Okay, let's see how many function calls we are doing. Okay, so first of all I am going to call this function solve to 10, which is nothing but 2 power 10 that I want. Okay, already I hope you understood. This is the 1024 is my answer, that is 210. I'm going to solve this. Okay, see clearly. So first of all what I am going to do is x is 2, n is 10, which is 2 power 10. So I am keeping a variable half, which is nothing, I don't know now. So as I said, each function call. So this is the first function call will be created now. So this is solve 2 comma 10. So this function call will be going to call now x is equals to 2, n is equals to 5. You can clearly see the n has become half. So here also I don't know half. So here I will be going to have solve 2 comma 5 function call. Again what I am going to do is, again x I have 2 and n is equals to, again you need to do half for this 5, which is 2.5 just in integer, that is 2, and again I don't know what is the half over here. And finally again I need to calculate x is equals to 2, n is equals to 1 by 2, which is nothing but 1, and half again I don't know. And here we have solve 2 comma 2, and here we have solve 2 comma 1, and finally once again which is x is equals to 2, n is equals to 1, half is equals to, we don't know, sorry, half n is equals to 0. Why n is equals to 0? Because you are doing 1 means 1 by 2, which is 0.5, sorry 0. So as actually that is 0, but you are taking integers, so that is 0, then we need to consider n. Okay, So half we don't know. So finally we are going to call sol 2 comma 0. So I hope you can see clearly we are calling how we are calling the recursive calls. Okay, and after finally you can clearly see here. So at the end you are going to see something like recursive stack like this. So assume this is the recursive stack. First of all, sol 2 comma 10 will go here, sol 2 comma 5 will go here, sol 2 comma 2 will come here, sol 2 comma 1 will come here, and finally sol 2 comma 0 will come. As soon as 2 comma 0 comes, it is going to pop out. Why it is going to pop out? Because this is the base condition, and it will be going to return in half value here. Okay, after returning an half value, we are going to check this x and right x n. Solve x and we are passing, right? We are going to check this one is even or odd. As this is the even or odd that if we find out, so with that we are going to have two conditions. So as you can see in the code that I have written, if x is even, I am going to just multiply half into half. If x is odd, I am going to multiply x into half. So after that the recursion stack will looks like this. So we have sol 2 comma 10, sol 2 comma 5, sol 2 comma 2, and finally we have sol 2 comma 1. So after this, so sol 2 comma 1 will be destroyed, this will be destroyed, and we need to calculate half here. How we can get half here? So generally half is equals to 1, because we can see 2 into 1 into 1 is equals to 2, because here you can see an exponent, right? N is odd. So x into half, that simply as that I showed you now. Half is what? Half is 1 here. So x into half, that is 2. So 2 is written from here to here. So after that this is also completed. So here also we need to calculate that. So as again you can see here, the 2 is like the thing. So you can see that is even. So we can simply say 2 into 2 is equals to 4. Okay, we are returning the half as 4. So finally this will also get popped, and finally we are going to have something like this. So finally sol 2 comma 0, and finally we are going to have sol 2 comma 5. So here here we are going to have half as 4, which is coming from here. So this is half. Okay, x is equals to 2, n is equals to 5. Okay, you can see over here x comma n this is. So I am going to calculate again means x into half, which is 32. So after this finally I am going to call here. So I am going to destroy this sol 2 comma 5. So I have destroyed this, finally I have left with sol 2 comma 0. So finally this is 10. Okay, 2 comma 10 we have left with. So finally, so for destroying this also, what we need to do is we need to have the half here. What is the last half? Last half is 32. What is x? 2. You can see over here. What is n? N is 10. You can also see here. It means which is 2 comma 10. So finally we have half value, x value, n value. So as we can know that n is 10. So x into half. This is for odd. So we should not do this. So for the even we need to do half into half. So which is nothing but 32 into 32, as you can see. That is half is 32. So we need to do 32 into 32, that is 1024. So finally we have got the sol 2 comma 10, which is 2 power 10, which is 1024, which is exactly correct. If you have only one recursion call, so then we can simply say it is simple, because only one recursion call means nothing much complexity is involved over here, and we can simply see that all that is linear structure. That is, the recursion call is linear structure and simple backtracking, nothing complex. So if you see a function recursion calls like involving multiple function calls, like if you see function call of n over here plus another recursion call like in this format, so it will form recursion tree, like one will call here, another call will here. So it will happen like this if you have multiple function recursion calls like this. If you have the even value, you do half into half. If you have the odd value, you do half into half. X into half into half. So I hope you understood this video. Thanks for watching up to now.